أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم.
Now we start exercise 1.2, question number 1. Prove that real iota z is equal to minus imaginary z. Let z is equal to x plus iota y. Now we can put the value of z real into iota x plus iota y, putting the value of z and equal to minus imaginary into x plus iota y. Multiplying iota within brackets, iota x plus iota square y. Here imaginary part is y and minus remains as such. Now re real into iota x, iota square value minus 1 minus y comes. Real part is minus y equal to minus y, hence proved. Part number 2. Imaginary iota z is equal to real z. Let z is equal to x plus iota y. Imaginary iota into x plus iota y, real x plus iota y. Multiplying iota within brackets, iota x plus iota square y. Here real part is x. Now iota square value minus 1 and now imaginary value is x is equal to x, hence proved. Question number 2. Using algebraic properties of complex number, prove that z1 z2 into z3 z4 is equal to z1 z3 z2 z4 equal to z3 into z1 z2 z4. Taking left hand side, z1 z2 equal to z3 z4. We can write as z1 here, z2 z3 equal to into z4, which is associative property of multiplication. Now we can write z1 z2 z3 as z3 z2 into z4, which is commutative property of multiplications. Similarly, now we can write z1 z3 into z2 z4, which is associative property of multiplication. Now we can write z1 z3 as z3 z1, z2 z4 remains as such. We are applying here commutative property of multiplication, and now z3 comes here, z1 z2 within brackets and into z4, hence proof, which is the answer. Prove that for z belongs to complex number. Question number 3. Z is real if and only if z is equal to z bar, z conjugate. Let z is equal to x plus iota. Real z is equal to, as real part is x, conjugate of z bar is x, and z is equal to z bar. We can prove in another way. Method 1 is, now we discuss second method. Let z is equal to x plus iota y, z bar is equal to x minus iota y, z is equal to z bar as given in equation. Putting the value of z and z bar, we taking x minus iota y here it becomes minus x plus iota y, x cancelled with x, 2 iota y is equal to 0 and y is equal to 0, as 2 iota is not equal to 0, so y equal to 0. Now put y is equal to 0 in equation 1, which is z is equal to x plus iota y, as y is 0, so it becomes 0 iota and z is equal to x. Now conversely, suppose that z is real, we shall prove that z is equal to z bar. Since z is real, so z equal to x, z bar equal to x, and z bar is equal to z, and hence proved. Question number 3, part number 2. Z minus z bar is equal to over z plus z bar equal to iota imaginary z over real z. Let z is equal to x plus iota y, z bar is equal to x minus iota y. Putting the value in above equation, putting the value of z, x plus iota y minus z conjugate x minus iota y over x plus iota y plus x minus iota y, putting the value z and z conjugate. Now iota into imaginary z is y and real z is x, iota into y over x. Now we solving this equation. X plus iota y minus x minus plus iota y over x plus iota y plus x minus iota y cancel with iota y plus iota y minus iota y plus x minus x is equal to 2 iota y over 2x. 2 cancel with 2, iota y over x is equal to iota y over x, hence proved. Question number 3, part number 3, z is either real या pure imaginary if and only if z bar square is equal to z square. Suppose z bar square is equal to z square, we shall prove that z is either real या pure imaginary. First of all we let complex number z is equal to x plus iota y, and we use above equation z square is equal to z bar square, putting the value of z as z is equal to x plus iota y. Here z conjugate will be x minus iota y. Now opening the square, a square plus b square plus 2ab, a square plus b square minus 2ab. Now x square iota square value minus 1 minus y square plus 2x iota y. Here x square, putting the value of iota square minus 1 minus y square and minus 2x iota y. Now we can cancel, take it here. Here it becomes minus x square plus y square plus 2x iota y minus 2x iota y. X square minus x square is cancelled, minus y square plus y square cancel, 4x iota y remains, 2x 4x iota y. Or xy is equal to 0. So either x is equal to 0 or y equal to 0. If x equal to 0, z is equal to x plus iota y, z is equal to iota y. And if y equal to 0, z plus iota y, y 0, so z equal to x. So z is pure imaginary, here z is pure real. So it is proof. So we conversely propose that z is either pure imaginary or real या pure real number. So we let z is equal to x plus 0 iota and pure imaginary 0 plus iota y. It remains z is equal to x, z bar is equal to x, as there is no iota term, conjugate remains as such. So z is equal to iota y, z conjugate will be minus iota y. Z bar is equal to x and here z bar is equal to minus iota y. No, using the equation z square is equal to z bar square, putting the value of z x square, z bar x square is equal to x square, hence proof. No. Part imaginary parts, if z is imaginary part, it's conjugate minus iota y. Using equation z square is equal to z bar square, putting the value of z square iota y, conjugate minus iota y, taking square, iota square y square, iota square y square, minus sign as power is even, minus sign absorbed. It becomes, putting the value of iota square, it becomes minus y square minus y square. Question number 4. If z1 is equal to 2 minus 3 iota, z1 z2 mode is equal to 16, find z2 mode. z1 is given 2 minus 3 iota, taking mode of z1, which becomes 2 square plus minus 3 square is equal to 4 plus 9, 13. 13 square root. And now putting the value in this z1 and z2 mode is equal to 16 and z1 mode is 13 and z2 mode remains as such, as we find z2 mode, and z2 mode remains here and 13 comes here, 16 over 13 square.